Hello and welcome. This is the Asylum and it's time for the Daily Gas. Today's gas is by Philip Newman and it's called Fortress of Similitude. Normal Sudoku rules apply, so we put the digits 1 through 9 in every row column box. And then it's a fortress Sudoku, which means digits in gray cells need to be greater than the digits in orthogonally adjacent white cells. And orthogonally means they're just connected along an edge. The diagonal cells we don't have to worry about, but the ones that are connected by an edge need to be smaller than the gray cells. And that's all the rules. Let's get started. Now the first thing I notice is that there's a 3 in a gray cell here, so these have to be 1, 2. Now there's a 4, so these are 1, 2, 3. And you're not a 3. What else do we see? These are 1, 2, 3. These could be basically anything. This is an 8 or a 9. This is an 8 or a 9. This is an 8 or a 9. This can't be a 9. Wait. Hold on. Oh, white cells. Right. So it doesn't matter. Fortress cells can be bigger than each other and not worry about it, like this 5, 7 here. Yeah, that's totally cool. I'm assuming this is a 5, but I can't prove it. It could be a 4 with a 3 here, or even a 2 with a 1 here. No, it can't be a 2, but it could be a 3 with a 2 and a 1 here. So it's 3, 4, or 5. This can't be higher than, well, I mean, it can be 8, but it can't be lower than, well, it's 6, 7, or 8, and it's not a 7. It's a 6 or an 8. It can't be a 6 either. That's an 8. We've got a digit, people. We've got another digit, and another digit. That makes this 7, 8, or 9. This can still be a 5 easily. Or it could be 7, 8, or 9. It's probably a 5, to be honest. This is a 7, 8, or 9, and it's not an 8. I thought that was going to do more, but it didn't. That's unfortunate. Seven has to go there. And 7 can't go there, so 7 has to go here. 7 can't go there because that would be, it would need a greater cell here, and 9 and 8 are gone. So that makes this a 9. We got a 5 there. That doesn't tell us much. That doesn't help me at all. This can't be a 2. It can be a can't be a 3. It's a 4, 8, or 9. If it was a 4, it'd need to be a 3-2 pair there. Well, it'd need to be a 3 here and a 2 here, specifically. If it's a 4. But we don't know it's a 4. So this can't be a 2. So the 2 is here in this row. Since a 3 and a 2, yeah, 2 is in one of those 2 places. Well, it can also be here, if this was a big number. Oh, well, no, it's the white cells, so it doesn't matter what these others are. This can't be a 9. This can be any number of things. 1, 3, 7. Since I don't know what these are, I don't know what this is. Especially since this could easily be a 1, and that makes either of these possible. Neither of these are 2. And a 2 isn't here. Wait, why isn't... Yeah, so this is a 2. Okay. That's a little progress. Because this can't be... Or this could be a 2. Hold on. These can't be 2, but why can't this be 2? I think I just did a leap there that was wrong. Yeah, that could easily be a 2. This is 6, 8, 9. It's not a 6. That's an 8 or a 9. Because it can't be 1, obviously, because it wouldn't be larger. 2, obviously, because it wouldn't be larger. 3, because that would require 1 and a 2, and that would blow this cell out. 4 is in the box. 5 is in the box. 6 is in the column. 7 is in the box. So it's an 8 or a 9. That gives us an 8-9 pair, which gives us a 5 here. Which gives us a 5 here and a 4 here. That gives us a 1, 2, 3 triple, so this is a 4. This can't be a 3. Because if it was, it would require a 2-1 blowing this cell out. It's a 5. And we've got a 1, 2, 3 triple. Another 1, 2, 3 triple. Well, 2 more 1, 2, 3 triples, to be honest. Oh, this can't be a 7. I don't know why there's a 7 marked there. It's a 1 or a 3. That's a 2. That's a 3. That's not. That's not. That's a 1. That's not. That's not. And that's not a 2. There's a 1 in this row because the 1 can't go in the fortress cell and it can't go in this column. So there's a 1 in this row making this a 2, this a 1. This is not a 2. This is a 2. Not a 2. That gives us a 2 here in this row. That 1 fixes the 2 here and the 1 here. Meaning there's a 2 here or here. This is not a 1. This is, yeah, that can be a 1 or a 3. Okay. That's cool. This can be a 3 or a 6. This can be a 1, 3, or 6. This is high enough that this can be any digit, basically. The only place for 1 to go in this row is here, because it can't go in any of the fortress cells, and it can't go here. So that's a 1. And 3 can't go in the fortress cell, so 3 goes there. That's not a 7. That's not a 6. 7-9 pair means that is a 6. So this is 1, 2, it's 1 or a 2, or it can be a 5. No, it can't be a 5. So it's a 1 or a 2. That makes this a 3, and this a 2, and this a 6, and this an 8-9 pair, making you a 6. Yeah, I should have done that cleanup earlier. Alright, but we got it all cleaned up now. I mean, we're well into dinosaur time, but we're going to solve this thing. This is not something I'm familiar with, so I don't know any tricks. This is a 2. Well, that's a 4. That's a 7. That's an 8. That's a 9. That's an 8. That's an 8. So this is a 9. This is a 7. This is a 9. These are 3 and 4, and we know the order. These are 5 and 6, and we know the order. We know the order of these 3, 7 now. One, 4, 9, but we can't be a 9 here, so we're a 9 here. And we got a 1, 4. Oh, and there's a 4 in the column, so that's a 4, that's a 1. This is an 8, 7, and we know the order. That's a 2. That's a 4. No. That's a... Oh, that's a 9. Okay. So this is a 7. This then is not 6, 5, 4, 3, 2. It's a 1. Making this a 3, this a 1. And this an 8, this a 9, this an 8. This a 3, this a 1, this is a 5, and this is a 4. And we solved it in 2527, which is a dinosaur time. I'm not even going to look. But we solved it. That was Fortress of Similitude, and we didn't even break it. We just were a little slow. And that was Fortress of Similitude by Philip Newman. Good job, y'all. Thank you, and I will see you tomorrow.